This is CPM Calculus, Chapter 3, number 64. Using the definition of the derivative as a limit, show that the derivative of f of x equals to 1 over x squared is f prime of x equals to negative 2 over x cubed. So that is, show algebraically that the following is true. Okay, so we're going to show that f prime of x we know is going to be the limit as h approaches 0 of f of x plus h minus f of x divided by h, right? So let's continue to solve this algebraically. So f of x plus h, we know here's our f of x, so we plug in x plus h, so it's going to be 1 over x plus h squared minus f of x, well, that's just 1 over x squared, all divided by h, right? So what this equals is the limit as h approaches 0. And how do we combine these? Well, we need, in the numerator, we still have it all over h. In the numerator, we have a fraction minus a fraction. So to combine those, we need a common denominator. So what is the common denominator? Well, our first term we have x plus h squared minus our second term we have 1 over x squared, right? So what we can do is multiply this first term times x squared over x squared, right? And this second term times x plus h squared over x plus h squared. So then we're going to get a common denominator, right? That's going to be the limit as h approaches 0. Don't forget to write this. Then we have x squared in the numerator here over x squared x plus h squared minus, in the numerator here we have x plus h squared over x squared x plus h squared all over h. Okay? So let's simplify that. Now we can combine the numerators because they have the common denominator. We still have the limit as h goes to 0, or as h approaches 0. So we have x squared minus x plus h squared over x squared times x plus h squared, right? All over h. Well, we know when we divide by h, right, this is really h over 1. So that's the same as multiplying by the reciprocal, 1 over h, right? So let's simplify this even more. That 1 distributes and leaves it the same. The h just gets multiplied here. So that's going to be x squared minus x plus h squared over h, I'm just moving in the front, times x squared times x plus h squared. Alright, so now let's just simplify this. We have the limit as h approaches 0 of x squared minus, so what is x plus h squared? Well, in a bubble here, let me just quickly say x plus h squared. Remember, it's x plus h times x plus h. So we can use FOIL or the box method to get x squared plus 2xh plus h squared, right? All over h x squared times x plus h squared. Okay, I'm not going to do anything with the denominator yet. Equals, well, I can distribute this negative sign to all the terms in the parentheses. So that's equal to the limit as h goes to 0 of x squared minus 2xh minus h squared over hx squared times x plus h squared. Okay? And again, if you remember, the reason why we're doing this is because if we plug in h is equal to 0, we're going to get over 0, undefined, and so that means we have to keep investigating more. Okay, this becomes the limit as h goes to 0. Well, x squared minus x squared, they cancel out, so we have negative 2xh minus h squared over hx squared times x plus h squared. Alright? So in the numerator, we can factor out an h. So that's the limit as h goes to 0. Factor out the h, we get negative 2x minus just h now, divided by h times x squared times x plus h squared. Right? So we factored out that h, now we're able to cancel these h's out. Right? So that's equal to the limit as h approaches 0 of negative 2x minus h over x squared times x plus h squared. Okay? So I did a lot of steps here. Some of these you might have been able to skip. But now we're able to plug in h is equal to 0 to see as h approaches 0 what the limit's going to be. So if we plug h equals to 0 in the numerator, now we don't write limit as h goes to 0. The numerator we have negative 2x minus 0, right, over x squared times x plus 0 squared. So that's equal to negative 2x over x squared times x squared, right? That's equal to negative 2x over x to the 4th. And that's equal to negative 2, and that x cancels out with one of the x's in the denominator, negative 2 over x cubed. All right? And that is exactly what we wanted to show that the limit is, right? So quickly, let's review that if f of x equals to 1 over x squared, that's the same thing as in exponential form is x to the negative 2 power, right? Using the power rule, the slope function f prime of x is equal to drop the power, negative 2x, subtract 1, negative 3. And again, that negative 3 power means you can put in the denominator as a positive power, and you see that these are the same, right? But it was important that we do it using the definition of the derivative using the method above. All right. So this ends CPM Calculus Chapter 3, number 64.